Most people building a RAG system open their code editor first. That's the mistake. You get a basic version working in a notebook. It looks fine with your 5 test questions, and then real users start typing real questions. Suddenly, you're chasing bad chunks, answers with citations that point to nothing, data that's gone stale, and a feedback loop you never actually built because you never planned for it. So today, I want to show you a different way to start. We're going to map out a RAG idea inside Lucid before touching a single line of code, and by the end, you'll have an actual checklist of what to build. A RAG pipeline sounds simple when you say it out loud. Someone asks a question, you turn it into an embedding, you search a vector store, you grab the top matching chunks, you hand those chunks plus the question to a language model, and it gives you an answer. That's maybe 6 steps on paper. But the moment you sit down to code it, you run into questions nobody warned you about. What happens if the vector search comes back with nothing useful? What's your cutoff for good enough similarity? What do you actually log when something breaks? Which of these outputs even matter for testing quality later? None of that shows up in the 6-step version, and that's exactly why mapping it out first saves you time. Okay, let's open Lucid. Blank canvas, nothing on it yet. On the side panel, there's an AI assistant built into Lucid now, and instead of dragging shapes around manually, I'm just going to describe the system in plain English and let it build the first draft. I type something like, build a flowchart for a RAG pipeline, including the user query, embedding step, vector search, a scoring step for retrieval, re-ranking, assembling context, generation with the language model, a citation check, the final response, a way to capture user feedback, and logging. I hit enter, and within a few seconds, there's a full diagram sitting on the canvas. Look at what it actually generated. The main line runs from the user's query into embedding, then into vector search connected to a vector database, then retrieval scoring, re-ranking, context assembly, generation, a citation check, and finally the response. Off to one side, there's a feedback box that writes into a separate feedback store, and a logging node that connects back to earlier stages. Honestly, that's a decent starting skeleton. A lot of engineers building their first RAG system skip that feedback loop entirely, so seeing it show up automatically is a good sign. But it's still just a skeleton. The AI has no idea what similarity score you should trust, what to do when retrieval comes back weak, or which outputs you actually care about for evaluation. Those decisions are on you, and this is where the real engineering work happens. The first thing I always add is a retrieval quality rule with a fallback path. I hover over the retrieval scoring box, and Lucid shows small connector points around the edges. I drag out from the bottom point, drop a new box, and label it as the fallback response, the one that tells the user we couldn't find enough relevant context instead of letting the model guess. Next to the scoring box, I add a small note with the actual rule. Something like, if the top similarity score is under 0.7, send it to the fallback. Between 0.7 and 0.85, run it through re-ranking. Above 0.85, move straight to generation. This one decision point is probably where most RAG systems quietly fail in production. The retrieval comes back weak. Nobody told the model that's okay to admit, so it just fills the gap with something confident and wrong. Writing the threshold down before you code anything forces you to actually decide instead of leaving it to chance. Second thing, I go back to the logging box and get specific about what's inside it. Right now it just says logging, which tells you nothing. I open it up and list out the real fields, the query text, how long embedding took, which chunk IDs got pulled, their similarity scores, whether re-ranking kicked in, how long the final context ended up, generation time, whether the citation check passed, and the user's feedback if they gave any. That's 9 fields, and every single one matters the day a user says the answer was wrong and you need to figure out why. Vague logging means you're guessing after the fact. Specific logging means you can actually trace the failure back to its source. Third thing, and this is the one almost everyone forgets, marking exactly where evaluation data gets captured. I add a small callout near the retrieval scoring box for capturing retrieval relevance, another one near generation for answer quality, and a third near the citation check for citation accuracy. These 3 signals cover the real dimensions any serious RAG evaluation needs to track. If you don't decide upfront that these are the moments you're capturing data from, you end up trying to reconstruct all of this from raw logs months later, and that's a miserable task nobody wants to do. A few things I add on top of the basic scaffold come from stuff people complain about constantly on forums like Reddit's machine learning and LLM subreddits, not from any textbook. Chunking is one of them. People build a RAG system, feed it whole pages of text as one chunk, and then wonder why retrieval keeps pulling back half-relevant paragraphs mixed with the actual answer. On the diagram, right after the vector search box, I add a small note about chunk size, usually somewhere between 200 and 500 tokens depending on the content, with some overlap between chunks so you don't accidentally cut a sentence in half at a boundary. It sounds like a minor detail until you realize bad chunking is probably the single biggest silent killer of retrieval quality, way more than people give it credit for. Hybrid search is another one worth marking on the diagram, especially if your documents contain exact terms like product codes, model numbers, or names that a pure vector search tends to miss. Vector similarity is great at catching meaning, but it's not always great at catching an exact string match. So next to the vector search box, I'll add a parallel path for keyword or BM25 search, with the two result sets getting merged before scoring. You don't have to build this on day one, but marking it on the diagram now means you're not surprised later when someone asks why the system can't find an exact product code that's sitting right there in the documents. Citation checking deserves its own note too, because citation check as one box hides a lot of decisions. Are you checking that the model's answer actually quotes from the retrieved chunks, or just that a citation exists at all? Those are two very different levels of rigor, and the difference matters a lot if you're in a space like healthcare, finance, or legal, where a made-up citation isn't just annoying, it's a real liability. I usually add a short note here specifying whether we're doing a strict quote match or a looser semantic check, because that decision changes how strict your citation check code ends up being. Once all three of these are on the canvas, the diagram stops being just a nice picture and starts answering real questions. What happens when retrieval is weak? What gets recorded when something goes wrong? What data feeds your evaluation set later? And now this diagram is something you can actually hand to other people. Your data engineer can look at it and know exactly what the vector store needs to support. Whoever's working on re-ranking can see where their piece fits. Product can see where user feedback enters the system. Even leadership can glance at it and see where the risk points are without needing a technical walkthrough. The conversation shifts from, does this work, to is 0.7 actually the right cutoff? And that second question already has an answer sitting right there on the screen instead of buried in someone's head. By the time you close this diagram out, you basically have your first 3 engineering tasks written for you. Set the actual similarity threshold and build the fallback logic around it. Build structured logging that captures all 9 of those fields, not just a generic log line. Set up evaluation datasets for retrieval relevance, answer quality, and citation accuracy, and make sure your pipeline is actually writing to them. None of those 3 tasks show up if you skip straight to coding, because coding tends to focus you on making the happy path work first and everything else becomes an afterthought. If you're building anything AI related right now, especially agent-style systems with multiple steps and tool calls, I genuinely recommend mapping the workflow out before you touch code. It forces you to deal with the messy parts early. What happens when a tool call fails? When do you escalate to a human? Where does your evaluation data actually come from? And who owns each piece of the system? Those are expensive questions to answer after launch, and cheap questions to answer on a diagram.